Okay. So the first thing I might do, so this is, as you can see, we have scatter plot, residual plot. We'll talk about the normal probability plot when we check our conditions. And you can see we have, but we also have these kind of like summary statistics right here. Okay, so I want you to imagine I gave you this. It's a free response question, and the first thing I'm going to ask is, what is the equation of the line of fit? Or what is the equation of the least squares regression line? Okay, so in reality, what I'm asking you to do is find the equation of the line, which is probably approximated, give or take, with the one I just drew, that line of best fit for this particular scatter plot. Okay, so what are my expectations if I ask you to calculate the line of fit? And the answer is, all right in this column, a reminder that your slope is the coefficient of the x-coordinate, and your y-intercept is a constant. Okay? So in this case, we would what I would hope to see is something like grade hat equals 12 times study time plus 62.1. That's my line of fit. If you wrote this in y equals mx plus b form and just used y and x, that would be fine, but that you would then need to go in and define your variables. So I would look for, is it clear that your x variable is study time, your y variable is grade, you have a hat, and you have the slope and the y-intercept appropriate. Is everybody with me? If you flip-flop the order of these and wrote this as 62.1 plus 12 times study time, not a problem at all. Okay, but the 12 needs to go in front of the study time because it is the coefficient of study time. Everybody remembering this from just like when we did lines of fit. Okay, the next thing I might ask you to do is interpret the slope. If I ask you to interpret the slope, what is my slope? 12. Well, the slope is just the 12, yes? And if I had to write that 12 as a fraction, it would be 12 over 1, okay? And let's see, are you guys with me that slope in general in our heads is change in y over change in x? So that 12 is my change in y, which in this case is change in grade. And the 1 is my change in time, study time. So that's to help me come up with the following sentence. For every additional hour of study time, the grade is predicted to increase by 12. And it is likely you might have to either interpret the slope or the y-intercept on your test. What if I asked you to interpret the y-intercept? First of all, what is my y-intercept? Well, so the y-intercept is the coordinate pair 0, 62.1, which goes with 0 hours of studying. So a person who does not study is predicted to earn 62.1 points on the test. Okay. And I won't tell you which one, but you will have to interpret either the slope or the y-intercept on your next test. So I want to give you a quick reminder of what to do with that, okay? If it's anything else from regression, I will do more of that review later on, either today or tomorrow, okay? All right, so let's keep going with doing a significance test for beta. What would the slope of our line look like if there were no relationship between our two variables? Flat. 0. Yeah? Okay. So if I'm doing a hypothesis test or significance test for beta, my null hypothesis will always be that there is not a relationship between my two variables. In other words, the slope of the line relating them is 0. It's not positive, it's not negative. There's nothing going on between the two. Okay? My alternative could be any of the things, right? It could be greater than 0, it could be beta is less than 0, it could be not equal to 0. It just depends on the verbiage of the question. My conditions for a test for beta are identical to my conditions for an interval for beta. Okay, so we're going to check all of our conditions the exact same way. So let's take a look at this. For this example, my null hypothesis would be beta equals 0. And let's see. As I go to my question, it says, do these data provide convincing evidence that there is a linear relationship? Does not say positive, does not say negative. So it's basically just asking, is there a slope other than 0 going on here? So in this case, my alternative would be not equal to. Yes, because we checked the linear condition, so it ends up. Guys, if those are my hypotheses, the appropriate procedure is a t-test for beta. What are my conditions? What's the first one? Linear. Is that met?
Yes. There's no pattern on the residual.
No pattern on residual plot. Okay. Next. Independent.
All grades are independent.
Individuals' grades are independent. Okay, we haven't talked about normal probability plots. We did a little bit in Unit 7, but not a ton. So just a reminder, what a normal probability plot does is it takes your variable on the x-axis, which in this case, we're trying to decide are the residuals give or take normal, okay? The y-axis of a normal probability plot is what the z-score should be if they are normal, okay? In other words, like this person is roughly the 10th percentile. What is the z-score of the 10th percentile if normal? Okay, so if these follow a straight line, then you can say the residual, then you can say whatever that variable is, in this case the residuals, are approximately normal. And what would look like if it wasn't is it was kind of like either tailed this way or tailed that way, and same on the other side, okay? So in this particular case, what I would say is that the normal probability plot shows a linear pattern. So the residuals are approximately normal. Okay, E. E is that equal standard deviations or equal variances. And what that means is the spread of the y's is similar all the way through the x-axis, right? So like I could look at it as saying the y coordinates right about here have the same spread as the y coordinates from here is here. Another way we do that is we look for, is there any fanning in our residual plot? In this case, we would say no fanning in the residual plot. Okay.
What would you say if you don't have the residual plot?
I won't ask you to do this without one.
On the AP test, are we allowed to write like outline?
I would say instead of writing what linear. Yeah. Yeah. You won't have to do this on the AP. Like, I would bet thousands of dollars. I would bet my entire year's salary that you will not be checking the conditions on a linear regression inference on the AP exam. I have to teach it to you because it's in the AP curriculum. I would bet my entire salary for the year that you won't have to do that.
Okay, cool.
I mean, I'm not going to shake on it or anything because that's pretty risky, but like when I say shocked, I mean I would be flabbergasted if you had to do this on the AP exam.
Is our AP test going to be on paper, pencil, or online this year?
The multiple choice will be online. The free response will be Blue Book. So what that means is the questions will be online, but you'll write your answers down in a book.
Do we have to take it in the library?
Probably. You can't take it in here. I'm actually not allowed within a certain radius of you guys while you take it. Also, you will not be allowed to discuss it with me. In fact, I might take that entire day off. Like, you guys are going to take it in the morning, you'll be here in the afternoon. Like, you can't be like, oh my gosh, this question 6 said this, and you can't talk to me about it until the free response questions are released. It's just the rules. It is just the rules.
So you get to see your answers in the page.
I don't know. This is the first time they've done it. Like, it has always been full paper pencil until this year. So I don't know. I think what we will, your final you are going to take online, and I'm pretty sure it is the same interface as when you, like, I'm going to do the legwork so that it's as close to the interface as when you take the actual AP exam, so you can get a feel for that kind of stuff. But I think there are online tools where you can highlight or underline and all that kind of stuff. But I don't know for sure. You guys are guinea pigs. This is the first year of it. So, yeah.
I don't like testing at the library. I don't know, it's just kind of a distracting room.
The garage door will be down. It'll be Mr. Wheeland and Dr. Carter. All right, guys, we just did the hardest part of this whole thing. Because the next thing we need to do are our calculations, yes? Which means we need to find the t-statistic and p-value of our sample. I'd just like to remind you, yesterday we learned that calculations regarding slope are in this line. Does anybody see where we might find the t-statistic and p-value of our sample? Do you guys see the T and the P? Okay, which means our T statistic is equal to 4.25. Now, I want to talk about that p-value a little bit more, okay? All right. Now, when we get one of these tables, this p-value in a table like this one, every single time is a two-sided p-value. In other words, picture-wise, if I asked you to calculate that by hand, what you would have is a t-graph shaded on both sides. Okay? Now, I know I do this on your test, so we're going to talk about it real quick. Okay? On your test, there is a multiple choice question in which I give you the T statistic and ask you to come up with the p-value. So I want to remind you guys how you can use a T statistic to come up with a p-value. Every good? Okay. First, we got to decide how many, if it's T, my calculator is going to ask me for 8 degrees of freedom, which means I need to know what the degrees of freedom are. A reminder that when our test is about slope, I have an X variable and a Y variable. It's not my sample size minus 1. It's my sample size minus 2. What's my sample size here? 10. Which means my degrees of freedom is 8. Okay. Guys, can you go into your second VARS menu and look at option TCDF?
So wait, how did you get
The T statistic I gave you up here.
no,
Degrees of freedom?
yeah,
Your sample size minus 2.
okay.
If it's a test for a mean, it's your sample size minus 1. And there's 2 ways you could decide what the sample size is. You could count the dots. Or, I told you I took 10. Cool?
Yeah.
Every good. And you guys, if I'm not very smart, but I bet you get something like 0.0014. I mean, I did this 4th period. So you guys, based on, huh?
Do you say that to fourth period a lot?
Not as often as I say it to you guys. But I still kind of knew what the answer was going to be. Wait a minute, you guys, hold on. Based on this picture, what is my p-value? .0014 plus, and should this be two-sided, by the way? Two-sided, my alternative was not equal to, yeah? So it should be two-sided. Is everybody with me? So I'm just going to take that times 2 to get the two-sided p-value, and I get 0.0028. Another way I might call that 0.003, which, is the exact same p-value as I give you here. Yeah. So this is the two-sided p-value. I just went through this because it's reasonably possible, arguably very, very likely, Sylvie, you can't see this at home, but I'm winking at everybody, that one of the multiple choice questions is literally going to say, here's your test statistic, what is your p-value? Okay, and so you need to be able to find your p-value from a test statistic. Yes?
We're just trying to find the alternative is greater than, would it just be the 0.0014?
Exactly true.
Are we ever gonna have to find T and P?
No. Oh, man. That would be like a super cruel and not very helpful question to ask.
How would you
Why wouldn't you just do it backwards?
invert it
And you do inverse T, I suppose, but
and then find the greatest?
yeah, I don't know. What if my alternative was less than or equal to? What would my p-value be? Here's a hint. Not 0.0014, because my test statistic was this one, the positive one. No, it would be 0.9986.
Wait, what was the question? If it's
If my alternative was less than, it would be the area to the left of my test statistics. Is everybody with me?
Yeah.
But that's silly because you guys, if I got that graph and I got this slope, I'm not going to test that it's a negative relationship. I can clearly tell that this is not negative, yes? My example is terrible evidence of a negative relationship. Everybody good? You guys ready? Let's do another one real quick. So where it says, does this provide evidence that there is a linear relationship? Could you guys go ahead and add the word that there is a positive linear relationship? Oh my gosh. Mostly because I want you guys to have to do a one-sided and a two-sided test. Everybody good? All right. So this one is talking about a psychologist who's working with couples who are getting divorced, and it's looking at the relationship between the length of their courtship versus the length of their marriage. Okay? Courtship being however long they were dating before they got married. Everybody okay? All right. So all right, let's pretend I'm dumb. What's my null hypothesis? Beta equals 0. What is my alternative hypothesis? Beta is greater than 0. But I don't know why you do that. You do that all the time. It drives me crazy.
I wrote it right about other way.
Like, if you wrote 0 is less than beta, it's fine. I just, like,
No.
and I feel like you do that a lot. And I'm like, why is he doing that? But it's fine. Because it's equivalent, yes? And then what else do you think I should write with this?
What beta is?
Beta equals the slope of the true line relating length of courtship and length of marriage. Okay, and given those hypotheses, what is the appropriate procedure? Danny, go ahead.
It's the t-test.
T-test for beta. Like, that part's important, okay? Like you're telling me which one it is. Because we also have t-test from you. So far, is this feeling pretty reasonable? Perfect. Let's keep rolling. Is the linear condition met? I don't see a pattern on the residual plot. Again, notice you guys, I'm referring to the graphs by name. Okay? Feels weird to say individual marriage lengths are independent because marriage is an individual. My eye keeps twitching. Which graph am I looking at to meet the normal condition? The normal probability plot of the residuals shows a linear pattern. The E is equal variances or equal standard deviations.
No,
It's
I know like what we write. I just didn't, I forgot what it meant.
there's no fanning on the residual plot. And R, we were given a random sample. Okay, test statistic and p-value. What's my test statistic? 3.68. Trick question. What is my p-value? Here's a hint. It is not 0.006. It's half of it. Okay, so based off of this, my picture would look like this. This area is that 0.006, leaving each of them to be 0.003. And since we're doing a positive relationship, we only care about the right-hand side. Because so when the program that does this doesn't know what your hypotheses are. So it always just gives a two-sided. Okay. And then since 0.003 is less than 0.05, we can reject.
Should I say positive linear relationship?
Yeah, I just did that before too. All right, so here's what's going on for the rest of till spring break. Quiz Friday. At this point, I have assigned all of the Unit 9 progress checks with immediate feedback for the multiple choice. Okay? You have your quiz review and homework that you received yesterday. Yeah? And then, literally right now, I'm going to go, I have the test even pulled up in front of me to immediately give you guys the free response questions. Like I said yesterday, I know that probably every teacher in the school is giving tests or projects or whatever next week. My thoughts on the test are, I would like you to have it done before you leave for spring break. So if you're going on one of the trips, it needs to be done before you leave on those trips. Okay? Right now I have scheduled for test corrections Thursday and Friday. I have no problem if someone would prefer to wait to take the test Thursday and Friday because you're slammed on other days. That's fine. Yeah.
For test corrections, that's the end of the day.
End of the 9 weeks, but I'll put the raw scores in probably the Friday after we get back for spring break. That is if I even remember to put the raw scores in because I'm talented sometimes. Okay. Do you guys have any questions for me or anything that you want from me resource-wise? Sylvia, I made a recording for you. I even speak directly to you in the recording because you're the only person who missed the notes today. I'm also still recording, so if you want to say hi to yourself. No? Okay.